sometimes referred to as the law of inertia. An object at rest stays at rest and an object in motion stays in motion with the same speed and in the same direction unless acted upon by an unbalanced force. For example, I put some book on a rolling chair and push the chair, then the book in the chair would have the same speed. And when I stop the chair, the book is still moving. Or if you put a coin on top of a piece of paper and pull the paper super fast, the coin would stay for a millisecond. Friction is the force resisting the relative motion of solid surfaces, fluid layers, and material elements sliding against each other.
Measure of static friction. The force required to keep the object moving with the same speed is a measure of sliding friction. What is easier to move, a box from rest, or to move it when it's already in motion? When the box starts sliding, the contact point on its surface do not get enough time to lock into the contact points on the floor. So, the sliding friction is smaller than the static friction. So, it is easier to move the box already in motion than to get it started.
Rubbing both hands together to create heat. A sled sliding across snow or ice. Skis sliding against snow. A person sliding down a slide is an example of sliding friction. Speed is the rate at which someone or something is able to move or operate. The average speed of an object is the total distance traveled by the object divided by the elapsed time to cover that distance. It's a scalar quantity, which means it is defined only by magnitude. A related concept, average velocity, is a vector quantity. A vector quantity is defined by magnitude and direction. Newton's second law of motion pertains to the behavior of objects, for which all existing forces are not balanced. The second law states that the acceleration of an object is dependent upon two variables: the net force acting upon the object and the mass of the object. A car with less mass have more acceleration because all three cars have the same force, so the car with less mass have more acceleration, which means the car with less mass is faster. That is because the formula for force is force equals acceleration x mass. Formally stated, Newton's third law is, for every action, there is an equal and opposite reaction. The statement means that in every interaction, there is a pair of forces acting on the two interacting objects. The size of the forces on the first object equals the size of the force on the second object. Momentum is the quantity of motion of a moving body, measured as a product of its mass and velocity. The more momentum which an object has, the harder it is to stop. For example, an adult has more momentum than a kid when they are running.
And today I will be exploring the topic of gravity. Gravity is defined as the force that attracts a body towards the center of the Earth or toward any other physical body having mass. But what does this mean? Well, mass is locked in a relationship with gravity, which means anything with mass has a gravitational force that spans long distances. You're made up of matter, so therefore you have your own gravitational field. But what about the Sun? That big hunk of mass that weighs 333,000 times the Earth and contains 99.86% of all the mass in the entire solar system? It must have more of an effect on us than Earth. But actually, since the Sun is about 92 million miles away from us, and since we are so much closer to the Earth than the Sun, the gravity of the Sun has minimal effect on us directly. The Sun's gravity affects the planets because of their relative size and distance from each other. But wait a minute. If the Sun has such a powerful gravitational force, why don't all the planets just fly towards it? Well, from our observations on Earth, gravity creates an attractive nature to mass, but there's a different story.
Acceleration is defined as the rate of change of velocity. It is thus a vector quantity with dimension length time. In SI units, acceleration is measured in meters second using an accelerometer.
Science is fun. Time and motion. 46. Acceleration. Now, let us look at the zany world of acceleration. Yes.
When an object is moving now, we say that it's accelerating. Look at this plane, for example. It has to go faster and faster in order to take off and leave the ground. It accelerates. Airplanes also have to land. This time they need to decelerate or slow down. Here we can see the force of friction causing this particular airplane to reduce its speed. To calculate the acceleration of an object, we get the change in the velocity and we divide it by the time that change of velocity takes. Acceleration is measured in meters per second squared. So, what does that mean? Well, if an object has an acceleration of 3 meters per second squared, it means its speed increases by 3 meters per second every second that goes by.
So, acceleration tells us how fast the speed of an object is changing. Yes.
Air resistance is the frictional force air exerts against a moving object. As an object moves, air resistance slows it down. The faster the object's motion, the greater the air resistance exerted against it.
Right? Now, if you look at them, they're exactly the same. Same color, same shape, put them together, same size, hold them side by side, they're exactly the same weight. And now I'm going to change a property just on one of them. I'm going to take this piece of paper and I'm going to crumble it as hard as I can. Just going to squeeze it and squeeze it and squeeze it and make a very, very, very tight wall of paper. Now, if you look at these two sheets of paper, okay, and I asked you a question, guarantee you're all going to get this question wrong. Which one weighs more? Is it A or is it B? Now, most of you are going to say it's B. And actually, they're exactly the same. All I did was change its shape. I didn't change its weight. Think about it. If you weigh 50 pounds and you put your hands in the air, you still weigh 50 pounds. If you're jumping into a pool of water and you turn your body up really tight and you're doing a cannonball, you put all of that weight into a small space, but you still weigh 50 pounds. The weight didn't change, I changed the shape. Now, I have a cool little fun story I like doing with these papers. I'm a little weird, but let's just pretend that these papers talk. And these papers lived in Paper Town. And all of a sudden you have this big guy walking, and he's like, and you got this small little guy walking. He's like, hey, what are you doing? Nothing. Why don't you move out of my way? Do you know who you're talking to? Yeah, someone very big. What? And very ugly. Now, of course, these papers get into this huge conflict, and then they get into this competition. They're going to have a race. So they climb on top of a mountain. The loser has to leave town. And the race is this. This guy thinks because he's bigger, he's going to hit the floor faster. So they climb on top of the mountain. Okay? Now remember, the loser, okay, has to leave town. Now let me ask you a question. If I drop these 2 sheets of paper at exactly the same spot, I'm changing nothing. I'm not forcing them. I'm just going to let them go. And the only thing that's different is its shape. The same exact thing. And I let it go. Which one is going to hit the floor first? A or B? Make a prediction. And now let's see. 3, 2, 1. Was your prediction right? I think it was. The ball of paper did hit the ground first. Now, does anybody know why? Well, you see, this large sheet of paper, it was really unfair. Think about it. Underneath this large sheet of paper is what? There's air. The ball of paper had just a little bit of air underneath it to move out of the way. This large sheet of paper, as he was falling, was moving through the air like doo-doo-doo-doo, 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 where the ball of paper had just a little bit of air to move, and it kind of was like, woohoo! Super fast. Now think about it, okay? That's what air resistance is. The air is resisting. There's resistance. So this paper has to move all the air out of the way, and the bigger the surface, the more the air, the more resistance, the slower it falls. Now, as you saw, the large sheet of paper did move really slow. The ball of paper did move rather quickly. And you guys can do this experiment at home. Try really big sheets of paper. Try really small sheets of paper. And ultimately, you're going to realize that the object that moves super slow through the air is the object that is extremely air resistant. And the object that moves extremely fast through the air is the object that's not air resistant. So now you know a little bit about air resistance.